We are here today for a free webinar. So let's go ahead with the webinar, starting with what upGrad Offline Learning Center is exactly. आपने अभी तक सुना होगा कि upGrad का ऑनलाइन में लेक्चर्स होते थे, बहुत सारे कोर्सेज भी upGrad अभी तक दे चुका है ऑनलाइन में, लेकिन ऐसे बहुत सारे कोर्सेज हैं जो हमें ऑफलाइन में स्टार्ट करने हैं. सो वी आर स्टार्टिंग विद दिस फर्स्ट ऑफलाइन सेंटर इन पुणे. Okay, we have very smart classrooms here, cutting edge facilities to enhance your learning environment. यहाँ पे आपको प्रैक्टिकल स्किल डेवलपमेंट के लिए आसानी होगी. यू विल बी हैविंग अ डाउट क्लियरिंग सेशन एज वेल. काउंसलिंग सेशंस प्रोवाइड होते हैं यहाँ पे. So these are the facilities that will be provided in upGrad Offline Learning Center. Now, the courses provided in this offline center are certification in full stack development as well as certification in data science with AI/ML. हमारी तरफ से आपको कोर्स खत्म होने के बाद अप टू 8 मंथ्स हमारे प्लेसमेंट अपॉर्चुनिटीज मिलती है. जो कुछ भी हमारे साथ हायरिंग पार्टनर्स है, यू विल बी गेटिंग दोज अपॉर्चुनिटीज हियर. सो वी हैव अनलिमिटेड जॉब अपॉर्चुनिटीज after completion of the course for the eligible learners. Now, the main reason that we are here today, that is the webinar on exploring career trajectories in data science with AI/ML. So the guest speaker today is Mr. Sumit Jain, who is a data scientist. He has worked with Microsoft as well as Jio. And this webinar today has been arranged by upGrad Offline Learning Center, Pune. Now, without taking much time of yours, I would like to request today's guest speaker, that is Mr. Sumit Jain, to please continue with his guidance.
Hey everyone, am I audible and visible? Okay, so I'm assuming that's yes. So I'll just start sharing my screen. Okay, hey, so let me just hide this. Okay, so hi everyone, this is Sumit. I am basically a tech lead in data science and machine learning at Avaya. So Avaya is basically a unified communications company, which basically been based out of US and almost in operations for almost like 20 years. I'm currently leading the generative AI innovations team at Avaya, and I've been working almost around 7 years in data science and machine learning. I have previously worked with companies like Microsoft, Jio, and a few of the startups, and works on products like Windows 11, GeoTV, GeoCinema, and a couple of robotics products as well. Mostly my experience is in product-based companies where I'm impacting products that particularly range users from 300 million to 1.5 billion users through applications of data science and machine learning over them. Essentially, my skill set is I'm a full stack data scientist, basically work on the entire pipeline of the data science process right from the big data to machine learning research, development, machine learning operations, stakeholder management as such. Currently, my role is basically technical leadership in transformation of the legacy softwares through AI. I am also a consultant as well as a freelancer that particularly, supports companies and individuals in helping them with consulting on AI. I'm also an instructor that particularly built courses for upGrad, also taught at Scalar, Advancer, and few of the other EdTech organizations, and took live sessions and build machine learning courses for them. In this session, we'll be basically, so I'll give you a quick overview for the session. In this session, we'll be basically looking after the, uh, the entire data science process. What is data science? The entire data science process, how to crack jobs in data science, uh, an overview of generative AI, as well as any kind of curriculum highlights that particularly upGrad offers to you, and any kind of questions and answers that I can answer and help you with throughout the process that we'll be discussing over this. So as such, look, I'll be taking, since this is a 1 hour session, I won't go too much into depth, but because of the time limits, but I'll make sure that you would be able to understand what data science is from a layman's angle. And also, understand, what is the impact of data science on the industry? Why is it basically so popular, as well as, how to crack a data science job, right? So this is something that I'll be covering into this session. So let's go forward. So what is data science? So if I talk about data science, usually data science captures a broad landscape. So it's usually not a single field. Like you say, hey, can you say finance, or can you say just computer science? It's not just that. Data science is a multidisciplinary field, right, which involved knowledge about mathematics, statistics, domain knowledge about a particular area on which you're applying data science into. All the, how does data can be handled, so engineering, analysis, warehousing, right, machine learning, which particularly involves three specialized techniques in machine learning: supervised, unsupervised, reinforcement learning, artificial intelligence, and computer science, right? So now, what are these Venn diagrams that you're seeing? So this is essentially called a Venn diagram. Venn diagram is nothing but it gives you an overlap on how much field is overlapped from one particular area to another particular area. So if I talk about the right side, you have computer science. So computer science is a bigger umbrella, right? Within which you have artificial intelligence, within which you have machine learning, and that particularly how the terms are being interchangeable. So you might possibly question, what is the difference between data science, machine learning, and artificial intelligence? So artificial intelligence is a bigger umbrella that comes under computer science, within which there's a umbrella that the circle that comes out, which is called machine learning. And data science is not these. So what you heard here about machine learning and AI is basically on this part of the circle, which is the blue one, right? Data science also involves machine learning, but it also involves mathematics and statistics, majorly the statistics part of mathematics, where some part of statistics are used in the applications of data science. And then it also involves the blue circle, which is basically domain knowledge and data. So domain knowledge, that means understanding of a domain knowledge. Or what I mean by domain knowledge, let's suppose if I'm applying data science in automotive industry, right? So you need to understand how does things work in automotive industry. So you may be a little bit of an expert, not a very high, very experienced expert, but like a good understanding of about the domain that you're applying for. Let's suppose you're applying in finance. You have a good domain about finance terms, right? How does finance cycles work? How does any kind of any kind of financial terms that particularly can impact it. So having that, why does domain knowledge is important is basically it gives you a biasness that you need from the domain into taking decisions over your data. Some biases are important, some biases are not, but some biases that are important make sense, because a particular number in a particular domain has a different meaning of a particular number in any other domain, right? So having a domain knowledge particularly helps in making decisions that you are making through data, right? At some point of time. Then comes the whole data side. So data side may be like, you have data stored in ERPs, databases, MySQL databases, Excel sheets, different data sources, right? So big data sources. So big data comes as a big part of it, because there's a lot of data being collected these days. So there's a big data engineering is a completely new field. not a new field, but you can say as a, a field which is completely separate out, and there's a whole lot of big data engineering that is particularly been there. So it's a different field, but there's some part of data engineering that you need to learn to make sure that you can collect your data, use your data, and manipulate your data to particularly use your for a data science process. So let's understand a bit deep dive on this, right? So as you go forward, what is the data science process, right? So a data science process involved, 6 to 7 stages. These are the basically core stages. We will also run about what are the non-core stages that also comes above and below these, right? So business understanding. So anything that we do in data science is about business, right? Business comes first. You can't actually ignore business and say that, hey, I'll just do data science and then forget about business. You have to always have a business mindset before you start any data science process. How will it going to impact the business, right? Will it reduce losses? Where are the losses coming from? Which ones can be solved using data science? Which should be targeted? How do you tackle, let's suppose, any kind of fraud that is there, any kind of biasness, any kind of privacy, a lot of other things that comes into it. Now, once you have understand the core of the problem on what are you trying to solve, you go with the data. You figure out where's the data to solve these problems. What data can I collect, and what data can I understand that particularly being more related to this problem for me, right? So if I just take an example of, let's suppose, let's just take a simple example of recommendations, right? Recommendation systems. If Netflix wants to, increase their engagement on the platform, right? How would they do it? They want to see that, more people see more amount of movies, and they keep engaged on the platform more, so that, and they see more content on the platform, right? So what they will do is basically they will go with, understanding what users like, right? Does he like what a particular user like, not a users, but a user, because they're personalizing to that particular user and they're trying to improve it. So the business problem here is improve the engagement on the platform, which is basically as general and as broad as could be. The data problem here is understanding what leads to improvement of the engagement on the platform. So where are all the data present? Like, is it an Excel sheets, SQL databases, NoSQL databases, Hadoop, cloud, Azure, AWS, GCP, wherever it could be, right? It could be anywhere. So understanding the source of data, that, I need to see that engagement in understanding what kind of content the user like, what are the his previous preferences, what are his current preferences, and based on, what a kind of genre, language, movie stars, or any kind of things that particularly the user particularly has a preference for. And then you figure out where is all this data presented, and you bring it at places, and you pick up like those 5% or 10% of data that is particularly useful for the problem that you're solving, right? Then comes as a data preparation. Is the data usable format? Like, data can be in any, raw format, particularly not particularly, the format that you're looking at. And let's suppose you want to see it in a good tabular format, like an Excel sheets or any kind of things, right? But it's basically in a, let's suppose a JSON. This JSON is kind of a format that particularly involves nothing but, a key value pair. If you know a little bit of, nothing but a curly basis, and then you have a key colon, you have a value, key, you have a colon, and you have a value, right? So maybe it can be in that format, it can be in any kind of format, but is it in the format that you need it? So you need to do all that data manipulation, data preparation, removing all the corrupt entries, all those things that particularly comes up. So you do some cleaning on the data, which is really a major chunk and really involves a lot of time. So you'll understand why these steps are important. So visualization of that data, exploratory data analysis. So visualization is like you sort of making a chart out of this data, that, hey, what is so you do some sort of visualization to understand how significant is this data, right? What are the features? So if I have like what do you mean by features is like, what are the columns that are important in this data? If I say that, for a user ID, what are the content he watched, let's suppose a content ID, what is the kind of genre that content ID belongs to, what is the kind of rating that he has given, or what is the amount of time engaged that he has done with the content, right? So all of these are columns in a particular data, right? Which of them are important for you? There could be like 100 of them. Which of them are important for you is basically help analyzes that you analyze this data and you basically visualize this data and do a sort of an exploratory analysis, data analysis, to understand which of these columns are important for me, right? As simple as that. Then comes a important process, basically model building. So model building is driven by the kind of problem that you're trying to solve, right? So you may want to see that, I want to figure out the affinity of a user towards what kind of movies, right? And who are these similar users toward these movies, right? So if I say that, uh, uh, if I say that, I'm trying to solve, let's suppose, a clustering sort of a problem. I want to cluster out users who are basically likes similar content. Let's suppose you likes watching science fiction, and your friend also likes watching science fiction. But how do I figure out that you and you or your friend likes the same content? Basically just by looking at the content that you're watching currently or previously watched, right? Or so I don't know, you two are friends, but you two like the same content because you're watching the same genre, right? So similarly, there could be hundreds and thousands of lakhs of users similar to you. How do I club all these users together into a single cluster so that I can feed the same similar kind of content to this particular bunch of users, right? So what kind of model I decide is basically I decide on what sort of problem I'm trying to tackle here. So these are the things that particularly you takes in consideration while you deciding the model. There could be hundreds amount of algorithm that particularly it may be there, not 100, but it could be majorly, you can say 20 algorithms maximum, like including supervised, unsupervised, or you can say 30 algorithms, including reinforcement learning as well. But in more majorly, your work can be done in supervised and unsupervised, most of the cases, right? Evaluation and testing, which is one of the most important things. So how do you know that you basically build a model and it's particularly working best or not? Is it actually serving the purpose of the business? Because at the end, business come at the center, right? So how do you evaluate the performance of models, accuracy, root mean square errors, latency, explainability of these models, right? So all of these comes in the evaluation process and testing process of the model, which is particularly, in fact, another research area that particularly works out. And the most important thing out of all is deployment, because that's where you particularly make value for the business, right? Are you deploying those models because you can do all sort of experimentation? You can experiment with different algorithms. You can experiment with multiple amount of data. But are you actually deploying on the on the platform of the product or of the business, that deployment actually will make sense for you, right? So does it run on the backend software? Is it fault tolerant? That I mean, can it handle any kind of load? How fast are those predictions that you're making or the recommendations that you're making on the platform? Like, what if the audience changes tomorrow? What if there's a complete landscape that changes tomorrow and their taste changes tomorrow? How would your model perform, right? Your location changes, your interest changes, like, so all of those things particularly come into picture when you particularly deploy a model. And then post deployment, all of those work has to be done to maintain that model, right? So deployment can be on any kind of platform like Azure, AWS, GCP, all these cloud public clouds. Or you can actually do it on your own servers, right? You can have your own set of servers and you deploy an API that particularly serve these predictions or recommendations through that API over your server itself, right? So it could be anywhere. So it depends on what kind of framework that your companies follow. right? So what are the areas covered in the process? So areas covered in the process, like I said, you have programming and computer science, which is particularly you have to know at least one programming language, which is basically Python and SQL. Most of the work can be done in these two. You don't have to do anything apart from these two. Python and SQL are good enough. A little bit basics of computer science, like basics of data structures, data can be stored, how can data can be queried, all of those things. Some OOP concepts, because if you're writing code in Python, you should know a little bit of OOP concept, because if you want to write a production level code, you should be basically using some sort of OOP concepts, which are used in softwares, agile methodologies when particularly being used in software companies, right? Libraries like NumPy, Pandas, Matplotlib, scikit-learn, TensorFlow, PyTorch, all of these are like data manipulation, then data visualization, then deep learning, or machine learning libraries, right? So these will have at least have to know about the basics on these. You don't have to learn everything of everything. You need to learn that 20 or 30% of the thing that makes the 70 or 80% or almost 100% of the impact while you are basically developing on this thing. So remember, data science is a field of a journalist. It's not a field of an expert. So you need not to be an expert in everything. You need to be a journalist in most of the things, right? That's what data science majorly is about. Because being that will give you, and you should know what to actually study, or we should know what to actually you should know, right? That's where you would know that where to make the impact, or what to learn. Because if you learn everything about everything, it will take ages, and you won't possibly able to implement anything out of that. So you need to, so that's where help of a mentor or a guidance gives you, what you should be focusing on out of all these things that are there, and what you should not be focusing on. Because you need to save your time, and within that limited time you need to make sure that you maximize it efficiently. Then mathematics and statistics, you have linear algebra, calculus, probability, and statistics. So touching up some points into these, some part of linear algebra, little bit part of calculus, little bit probability and statistics, just to understand more on the data science process. Analysis and visualizations, you have some data pre-processing techniques, expert data analysis techniques, visualization techniques. Uh, Machine learning, big data technologies like introduction to big data concepts, Hadoop ecosystem, Spark, NoSQL databases. Data engineering concepts like data warehousing, pipeline development, ETL processes. Some tools like Apache Airflow, which are used for your management of their pipelines, data integration techniques. These are all ad hoc things that particularly adds up apart from your data science process. Uh, Model deployment, so model evaluation related to techniques. Containerization is an important concept that you should know, because that's how you basically deploy your model. Majority of the cases out there in the market. Cloud services, basics of MLOps and deploying models. Similarly, you should know how to build an API, like API frameworks like Flask or Django, or particularly for Python applications. So you should know a little bit about these frameworks. They're not very difficult to learn. It's just basically you should know how to do it, and how to basically optimize your API so that it performs well. So a little bit of those side is particularly helpful. Soft skills and project management. Obviously, what you're building, you should know how to communicate, and you should know how to communicate to the stakeholders that it adds value. You can't say, hey, my model works 95% accuracy, and it's one of the best models. That doesn't guarantee that it will make money for the business, right? What makes money for the business is even a simple model that works good enough, but it hits the right areas in the business, right? So um, being expert in a job doesn't always mean that you will being expert in data science doesn't always mean you'll be expert in a job, right? You basically have to understand the intuition behind what takes the business, what shift the needles in the business, and then particularly attune your approach towards the data science process. So it's an interesting field to work into. You just need to have patience in learning, and trust that at some point of time you will become good. You'll have a better understanding of the system. So usually the expectation in a data science job is people think that most of the time you are basically doing cool stuff, which is using machine learning algorithm, AI algorithms, and then doing it on the machine learning modeling over the data. But that isn't the case. You are also also doing a lot of data manipulation majority of the time, and you're also dealing with a lot of iterations of that process. So you are taking some data, experimenting over it. Maybe it doesn't work. You're taking some other data, you're experimenting with different algorithms. So a lot of things works in different in iteration process. So it's not like your software development where this is the feature, this is the set of rules that you write or set of code that you write, and then it becomes the feature is now ready. It doesn't work that way. It's an iterative process. So you need to make sure that you are basically keep experimenting. So it's like that's why I say that's why it's called data scientist, right? What does a scientist do? You experiment. They experiment on different things and they figure out ultimately what works and what doesn't. So most of the job is experimentation, but if you become an expert, you won't have to do much. You just need to know what works, because you know what works most in certain kind of problems and what doesn't work in certain kind of problems. So your job becomes more easy. So it's not just Kaggle competition. So Kaggle is a website that particularly holds these data science competitions. So Kaggle is a hub for data science. So if you want to learn about some of the projects or competitions in data science, you go to Kaggle, you see a lot of projects there, a lot of problems there that are solved. People post their solutions, everything is there. So you can basically check it out. But just remember, data science isn't just preparing data and training models, generally that particularly seen in Kaggle competitions. Data science in industry is a completely different game, right? That is data science in particularly a competition or all of those things. So like I said, you'll spend a large fraction of time scoping the business objective requirement with the stakeholder even before you build your first model or MVP model. Like your job doesn't end after training a model. That's just a beginning. Your model needs to be calibrated for business metrics, primed for deployment, and then maintained after the deployment. Your modeling procedure won't always follow the project steps sequentially. You will often need to shuffle between the scoping, preparation, modeling, and back to scoping. Okay, like I said, it's an iterative process. So there's a simple use case of a self-driving car. How does a self-driving car uses AI to you know uh, to basically make decisions, right? So you might know about some self-driving cars a little bit, but I'll just give you a gist about it. Don't it may be maybe example that you might not fully understand if you're basically first time acquainted with data science, but I'll just give it a try for you guys. So uh, so basically, if you look into self-driving car, you basically have a left camera, center camera, right camera. Like you're looking at all three directions, and your steering wheel should be adjusting going to it, because that's how self-driving is, right? You don't have a driver to it, so you need to adjust your steering wheel. Now, adjusting for shift and rotation involves deep learning into it, which is also a type of machine learning, right? So deep learning comes inside the machine learning circle that I showed you, right? It's a specific area of it. So what it does is it looks into the all three images that comes from all the cameras and understand if there's any object that particularly has to be tackled. Let's suppose there's a dog coming up over you in front of a car. You need to shift your steering wheel a little bit of like 2 degrees or 3 degrees to make sure that the car dodges the dog, right? So bypass the dog. So you need to make sure that the car does it, not you. So you basically instruct your car that there's an obstacle coming at this particular angle. So the car has been trained that way that whenever the obstacle come into the range of view, it has to make sure that it has to shift right or left, depends on where it's moving, right? And the deep learning model that is running inside the car, it basically takes a decision and allows the car to shift the and rotate on a, let's suppose, right side if the dog is coming from the left, right? So But sometimes it happens that the model is not accurate. It's still learning. It's not the perfect model. It's still learning, right? It's learning through the feedback that is getting from the environment. That, hey, if I just turn the car 2 degrees, I could have done the job, right? But what I did, what the car did is it turned it like for 10 degrees, right? So maybe I should particularly understand that there's a difference in actual amount or optimum amount of shift that is needed, and that's why it's particularly that would have done the job. So it understand, it learns through that feedback, and it basically feeds back into the model, retrain the model, so the next time the car goes out in the field, it will basically try to perform that, the accuracy, with that accuracy. So it keeps on improving that accuracy. So that is one intricate process on how self-driving car in top overview works. But there are more intricate details, but we'll discuss them later. So next is how to crack data science jobs, right? So there are two primary pathways that you follow. So first you need to have a foundational data skills. You need to know a little bit of statistics. You need to know data analysis. You need to have an understanding of some of the data sources like Excel or databases, any kind of normal databases that have been used, and some sort of data visualization tool. So once you have those foundational data skills, then you have multiple roles that comes through those foundational data skills. So once you have those foundational data skills, you are eligible for a business analyst job that particularly involves some sort of domain knowledge, dashboards, Tableau, Power BI, and such things. And then once you become expert in that, you become a data-driven manager that particularly leads a team who has a deep understanding of a particular domain. Let's suppose you take a domain knowledge of a textile industry, right? Understanding of a domain knowledge of a textile industry plus having these foundational data skills becomes a good manager for you to leads around projects for in those kind of industries. Similarly, you could choose a field into data analyst first, and understanding there's a business intelligence area or role that generally comes into different companies, or data modeling, mining, or using Python, SQL, and data skills, basic data skills. Once you have these, you can possibly advance yourself to the next level. So either you can become a data scientist or you can become a data systems developer, which is basically similar to what you can call as data engineering these days, or big data engineering, or machine learning engineering, usually that a reversible term for data systems developer. So that particularly the pathways as you go from a very data focused area. So either you want something of business and data that particularly works hand to hand, or you go into a core data side that where you're data analyst or data scientist or data system developer sort of thing, right? So all of that comes into the depends on your interest, depends on what you are liking it when you basically have your foundational data skills. So generative AI. So generative AI is one of the most emerging field from the past 1 or 2 years in data science. So we added this here because we want to make sure that we will also be moving in that direction as we progress into this whole curriculum. So giving you a general understanding of what generative AI is, a sort of a demo, just give you a confidence that how a grid or particularly any courses over this area impacts a lot in the market, because generative AI is right now at the peak, and it's basically the kind of AI that's making the huge amount of impact in the industry. So we'll go forward what it is about. So generative AI is a new wave of AI that particularly rose up very recently, creating disruptions in many industries wherever any form of data is collected. So what it is. And so in layman terms, generative AI, you can assume is like a smart robot, or like let's suppose a specific part of it. What generative AI can do many general stuff, but let's take a part of an artist. What does an artist do? So it's like a smart robot artist that can create new pictures, stories, or music on its own, right? When I say on its own, that means you just need to instruct, just like you instruct a artist, hey, create a new picture for me, right? Create a new scenery for me, right? So you just tell me, hey, this scenery should look like, you should have a sun, it should have a car, it should have a astronaut, or it should have, let's suppose, anything that particularly entice you, right? So it should be like that. So you just give a verbal prompt to the artist to do this, and it particularly outputs you with all those things that you like your picture or art should be, right? And and similarly you can create stories for you, so you can make a writer, right? So you can make it as a smart robot writer and say, hey, I just need a story about how did I go on this trip over mountains, and then I walked over the river, and and how does all that process, I stayed in camps, did bonfires, and then put a flag over there, all of those things, and then make a story about it, so that I can I can club everything in a story. I can ask this particular thing by mentioning some of the few stuffs in normal English language, and it'll return a story for me of however words I want. Let's suppose I want it for 500 words, I want it for 1,000 words. It can elaborate in that way as well. So generative AI is generating content for you, right? Now, what works behind it are really large language models that are particularly working behind that, particularly doing this for you. Now, these large language models are very expensive to train. Usually companies like Microsoft, OpenAI, Google, Facebook, all of these are, Amazon, all these companies are basically doing it, right? So because they have, they're investing tons and tons of money in collecting this data, tons of money in creating these algorithms, and then training these algorithms on GPUs and everything. But what we generally do in the overall in the market, which is basically the consumer of generative AI, is basically we are using APIs that are hosted by these closed source sources like these companies, or we are using the model that are open sourced by different other companies that are also generative AI models, right? So there's a different stages of generative AI that particularly will go deep dive when we learn more about it. So generally what happens, like imagine you show this robot a bunch of cat pictures. Instead of just remembering them, it learns what cats generally look like, their shape, color, sizes, and then using what it's learned, this robot can draw brand new cat pictures. It has no one has ever seen before. So it still look like real cat. So it's not picking up picture from internet. Like it's not like Googling stuff or doing it. It's just creating stuff, right? That's why it's better than a Google search engine, right? It's not picking up stuff that is already there, but it's creating on its own, right? Like wo Sanju ki magic pencil, sort of those kind of things, right? So you might have already heard of ChatGPT, right? So what is this impact of generative AI? Right. So generative AI is having a profound impact across a wide range of industries by basically enabling the creation of new innovative content, improving efficiency, and opening up new possibility on personalized and interactive experiences. So it like a lot of industries has this impact. So if you say art and design, now designers that are there, right? Designers, what they do, they create new designs, they create innovative designs. But my generative AI model, I just need to tell, a product manager, what does the product manager do? It tells a designer, hey, I need something like this that looks like this in a UI, right? It looks like, I need a shade of this color, I need this kind of design over the buttons or whatever, that looks like on software. I can do that with a generative AI model and it will just create it for me, right? So it's basically making an impact or helping a designer to do his job faster, right? Similarly, entertainment and media, right? You might have recently, they have created a model which basically you just need to write the text. Like generally you have films, right? Films have scripts, and these scripts are actually uh, converted to films, videos, right? I can just put these scripts directly into a generative AI model. It will generate a video for me. Is that level that we have reached right now in generative AI. So text to video is now something that particularly the latest thing in generative AI. So all of these deep fake videos that particularly see, fake videos of Donald Trump, fake videos of Narendra Modi, or whatever, any kind of fake videos that people are creating can be created by this also. But that's a misuse of that particular this particular area. So that's why they need to be careful on to make sure the bad actors that doesn't get hands of it and then use it wrongly, right? So you need to basically, there's an impact on entertainment media over there. Then advertising and marketing industry, they are being hugely impacted by this because it produces personalized content for marketing campaigns like images, videos, and text, and they're helping the marketers and advertisers to create these ads for you in like in a span of a minute, right, or even faster. So these are basically, having a generative AI experts in these industries will particularly, raise your value very fast, because in that sense you are particularly impacting a huge in a very short amount of time, right? What takes in a week for creating an advertising campaign, it basically can be done within a few hours, right? So that is the amount of impact that's basically making up. Fashion, healthcare, manufacturing, education, finance, all has similar kind of thing. So any industry that you are into, having this skill will particularly accelerate your value within that industry a lot. So demand of these skills in the market is unprecedented. So what does upGrad offers? So I'll be a little, in a little curriculum side right now, because that's what the webinar is about. So more or less, it's basically provided an advanced certification program in data science, which is basically of 4 months. You don't need to have any prerequisite that, I need to know this, know this, know that. No, it's basically start from the basics and takes it to a level where you can basically become a foundational data skills, as well as you should. If you choose to go forward, there will be multiple generative AI projects, data science projects that particularly also come forward with it. So number of generative AI projects is 4. Target outcome is AI-enabled data analyst or AI-enabled business analyst or such, right? There could be, about upgrade. So there are like almost 10 million plus learners in 100 countries. 5 out of 6 learners get positive career growth, 93% program completion rate, 6,000 plus career transitions from multiple careers like digital marketing, sales, electrical engineering, project management. So many careers that people are coming from, and then they're making a transition into data science. And then these courses, these are designed in such a way that people are able to understand those skills and then able to make a transition by particularly and upskilling themselves into these skills. There are 200 plus hiring partners that also upgrad has, but these are basically conditional, so you need to basically understand from the course expert over there. Now upgrades 360-degree career support. So you have like to build your resume, your LinkedIn review, all of those things are important part of this. So resume, I would say, is one of the most important part in a data science process, because you need to completely align your resume to data science, right? Because you say like I have 10 years of experience, I have 5 years of experience, doesn't matter but it's not something that particularly relevant to the field, right? Because you're moving into a career transition. Career transition takes you from a basic level, right? So you can leverage your experience and you can pick out the elements from your experience and then put it in a resume. But you can't say that your experience is going to help you there. But what's going to help you is all these skills and projects that you gain within the curriculum, because that's becomes your relevance of the research. So relevance is more important resume than quantity or years of experience there. Now there will be masterclass from experts from mag companies like Microsoft, Amazon, Alphabet, Netflix, Google, and such. One-on-one mentorships and interview preparation with these experts as well. There will be guided internships, interviews, question banks, and industry-ready employability tests. So there will be specific preparation for those areas as well, to get acquainted and get you better with these things. There are best-in-class daily offline and doubt resolution classes, 100 plus hours of tutorial and soft skills trainings, and 300 plus of hours of self-paced technical content. There are certain certificate in data science with AI. So you have either you can choose any one of them, like you can choose Python and SQL. That will help you become a data analyst and similar sort of jobs. Statistics and EDA, that will help you more into business analyst side. Visualization also helps in both. Machine learning, NLP, and generative AI will help you become a more data scientist oriented. So more of a machine learning engineering expert and generative AI expert. Similarly, interview aptitude and profile building are common in all of these. So that needs to be at least have to be there. These are different tools generally used in data science with AI, ML, and you need to you will get acquainted with these tools once you particularly learn certain courses. Now, there will be, as you go forward, there will be certain case studies like loan approval, EDAs, or leads scoring case studies, or Airbnb case studies or anything of that sort, right? So these are different sort of case studies that particularly helps you gives understanding of implementing the concepts that you're learning into the data science process, right? So these assignments will be particularly gives you an edge on where you're what you're learning, where are you actually implementing, and how relevant it is from any kind of industry use case that comes with a similar thing, right? If we talk about loan approval idea assignments, right? There are many startups and companies who are working on building these loan approval systems that particularly works entirely on AI or machine learning in the backend, and they gives you an near good decisions on near accurate decisions on should a certain person should be given a loan and with what percent confidence, right? I say that this person should be given a loan with 80% confidence. How is that 80% coming? Is basically all the calculation that the model is doing in the backend, right? Bike sharing assignment, right? So there may be some startup who's basically working on bike rental or anything of that sort, right? Like Ola or something of that front, right? So how does that kind of thing particularly can be done, or there may be some bike sharing is like in terms of like blah blah cars or something similar concept. There may be those how does those startups in the back end can use AI to particularly make decisions for who to give, and what is the reliability of the person. All those are particularly things that particularly comes with data, and you particularly use them, learn them through these assignments, just to understand the industry use cases for them. So career transitions, they particularly have like 6.5 LPA average CDC, 6,000 plus transitions, 12,000 plus hiring partners, and like high CDC goes to 26 LPA. But there are stories that comes into it that particularly goes beyond these. These are just the basic figures, minimalistic figures that particularly being given. But there could be even more than that. That depends on your hard work and your skill set that you particularly run, right? So these are just numbers that particularly gives you a direction on what it is. So it's not just there would be about students enrolling to this. There may be like very senior experts that are coming into this scenario. So their transition will be something on a different level compared to your transitions. So everyone has their own pace, everyone has their own line, and depends on their growth. It particularly can be aligned. So there's not hard and fast anything like that. So there's some testimonials from the previous people who have basically worked and enrolled into these course, and their ways of how they've experienced it and how they have worked it, right? So someone like Kushag has invested in practical skills of in AI that particularly helps him as an AI solution consultant into one of the AI companies that particularly helps him from previous almost like 120% hike. And it's normal. I'm saying at least in the early career transition, the hikes are really great because people are looking for experts, and if you're good at what you do, the growth is immense, right? So you can negotiate on anything. You can have 10 offers. You can have you can create your own demand. It largely depends on the intensity of your skills, right? So if you pay attention and do great work, I don't think there's a limit. So it's data science is currently, yes, it's true. So revolutionizing the way organizations leverage data to gain insights, drive innovations, make informed decisions by mastering the principles and techniques of data science. So it's an amazing field to go get into at present. And it will remain the most amazing fields to get into for the next 5 to 10 years at least. So that's what is like a rough estimate, but this is so much progress in the field that you won't even know it will still 5 years. But trust me, it's actually, you will be at least at the top of the, you know, top of the hierarchy in different technical skills, right? So it's but right now is the amazing time to get into it. Next amazing time will be, I don't know when, but at least now is basically the very amazing time to get into this field. So any Q&As, I'll be open it for like 10 minutes. So uh, uh, let me know how can I help or anything that I can answer. Okay, let me check out the comment section. Sure. So thank you so much, everyone. And it's a pleasure talking to you guys today. And I hope this session will help you, take a call on, how do you want to go into a data science journey, and give you an informed decision. So thanks so much.
Thank you so much, Sumit sir. So this was indeed a very informative session. I also thank each and everyone who was joined in this live session. I hope you have got a very good insights on this topic. And if you feel like sharing your opinions, sharing your thoughts, and if you have any doubt, you can always contact us. Everything is given in the description box. I again thank you, Sumit sir, for your insightful lecture today, and I declare that the webinar has ended. Thank you.
Thank you so much.